Hi, my name is James Montgomery, and I'm going to be talking a bit about Capital One and our approach to AI at scale, as well as bringing in the cutting edge in AI research for applications within finance. But before I delve into that, a little bit about myself and why I'm talking about this subject. So I'm a director of data science at Capital One, but specifically, I'm the data science lead for our behavioral models researching team. So my team primarily focuses on self-supervised learning for sequential models. And I've been doing that for the past 3 years, but I've been at Capital One for 9 years, 10 years if you count the internship. I do. 10 sounds like a nice whole number. And when I joined Capital One 10 years ago, the first tools that I was taught to use within Capital One were on-prem compute. We're using proprietary software. And over the years, I've been able to observe and participate in quite an amazing transformation at Capital One, going all in on the cloud, standardizing and modernizing our data ecosystem. As a data scientist, I loved that. I think once we standardized timestamps across our databases, I partied for 2 or 3 months straight. Going in and using open source software in place of proprietary software and building out what is now 14,000 technologists, machine learning engineers, data engineers, software engineers, more engineers than there are flavors at Baskin-Robbins, to maintain, build, and grow the systems and platforms that really make up the foundation of the work we do across Capital One, and specifically the research group that I'm part of. And it's been quite an amazing journey. It hasn't been an easy journey, and it's still going on. So there are a number of investments that we're continuing to make to improve the systems and ecosystem in which we develop and deploy and scale AI. So consider this talk more a snapshot in a journey where I talk about a bit of where we were, where we are, and maybe some hints about where we'd like to go. So I'll break it down. I'll start with talking a bit about what Capital One is and where we use machine learning. I've often found when I go to conferences, people are like, you guys are a bank. What do banks do with machine learning? And they come in with this look on their face expecting a very boring answer. And I like to think that when I give the answer, they walk away a bit more interested than they were to begin with. I'm then going to talk a bit about to scale AI, and especially bring in cutting-edge AI technologies. What are some lessons learned? I'm going to talk a bit about the human component as well as the tech stack that went behind that journey. I'm going to then transition to talk about some of the things we've been able to do this year specifically, building on that tech stack and using some of those lessons learned. And then, time permitting, I'll take some Q&A from the audience about the material that I cover. So what is Capital One? Capital One is a relatively young bank as far as banks go. It's about 30 years old. I like to call it young because it makes me feel young because I'm about 30 years old, despite all the gray creeping into my beard. But it's one of the nation's largest direct banks. A lot of us think of us as a credit card company because, our slogan, what's in your wallet. But we have quite a large retail and commercial bank. We have auto loans. We have a huge customer base of over 100 million customers in the US, UK, and Canada. We have a variety of products that we offer those customers that, we have a lot of things to optimize to improve each of our customers' financial state and really offer them a robust experience across all of their financial needs. But apart from just our customers, we also have 50,000 or so employees or associates whose experience we also want to improve and empower And so we think about AI throughout all of the solutions we create, products and services we create, both internally and externally facing. So being a little less vague, what are some of the areas that a bank thinks about machine learning? And these are some examples. So there's some really interesting ones that are adversarial. So there are ne'er-do-wells, nefarious individuals out there, which are trying to take advantage either of our enterprise or our customers or associates. So this would be things like fraud detection, cybersecurity, or anti-money laundering. So fraud detection and cybersecurity, we're mainly looking for things that don't belong or are anomalous that could be hints that someone is trying to impersonate someone else or is trying to fraud someone else to take control of their financial assets or infrastructure within Capital One. There's anti-money laundering, where typically organizations, human traffickers, terrorists, drug cartels, are taking large amounts of illicit funds and trying to move them across banks or within our bank to use for, again, evil, horrible things. But then we also have marketing use cases and acquisitions use cases where we're going out there and we're trying to find prospects and match them to financial products that are relevant and meaningful to them. We have our 100 million or so customers in our back book who we're trying to help service and make sure that they're having an optimal experience using our products and are aware of additional products that they might want to onboard to enrich their financial health. I love talking about fraud because it makes me feel a little bit like Batman going out there and preventing crime. But there's also a really great story here about how scaling AI and investing in the engineering required to scale AI had a material benefit in terms of how we deal with fraud at Capital One. So going back to 2018 or so, we were thinking about different types of fraud, and there are many different types of fraud: account takeovers, transaction frauds, merchant fraud. And transaction fraud was a really interesting space. So when you're a credit card company, a lot of the things you think about are payments and transactions. And transactions are an important part of the product that we provide and the experience we provide, and it's something you really have to get right. But transactions can be very difficult to get right. So for one thing, they can be very emotional. If you're standing in line at the grocery store with 3 bags of groceries, and there's a long line of people behind you, all grumpy, and you swipe your card and it's declined, that's not a great experience. It's very emotional, and not handling that correctly in the moment when it matters really hurts the experience and the impression of the product that the customer has. Even worse is when we don't catch the fraud and a customer realizes that someone has taken their information and impersonated them, which is an equally distressing situation. Actually, 2 months ago, I woke up at 2 a.m. with my phone ringing and realized it was Capital One. Yes, I have a Capital One card, telling me that someone had tried to spend 3 transactions of $600 each at PlayStation Online, all within 3 seconds of each other. Very suspicious. But luckily, Capital One had caught this, and proactively, in a personalized way, they told me the information that I needed to know. I knew that someone had attempted this. I knew that Capital One caught it. And I knew what the next steps were in terms of they were already issuing me a new card, and I was safe and secure. And it really was making the best of what could have been a quite horrible situation. So we had this problem of transaction fraud, and we wanted to make sure that we were getting it right. And so a few of the things we knew we needed to do was we wanted to be real-time and intelligent, which means using machine learning and having the ability to have those models run in real time. Now, real time is a very short term for something which engineers will understand is a very hard problem to solve. First of all, it means low latency. So when you swipe your card for a transaction, it's like waiting for a web page to load. No one wants to spend time sitting there in front of the point of sale waiting for the web page to load. So it's low latency. It's also high availability, and it needs to be fault tolerant, because this is not something you want to go down and have 100 million customers who are trying to use their products and very angry at you. So we knew we had to invest in a new tech stack, essentially a new platform to support these models. And so we made that investment in 2018. We unveiled these new real-time models, and we've noticed a few things since then. For one, the level of transaction fraud at Capital One is lower than our estimates of the industry rate of fraud, transaction fraud. Two, the volatility is also, or the variance is much lower. And there are a couple things contributing to this. So first, it makes sense that if you're using all of the information available right up until the transaction swipe, you're using as much information as you can to make the best prediction you can. Duh. The other thing is, and this is quite an interesting thing about fraud, fraudsters they're kind of like wolves. They go after the weakest in the herd. And so they're out there looking for banks that aren't investing in having the best fraud defenses they can. They're trying to make the quick buck. And so by making sure that we're not the weakest in the herd and that we're using what is the latest technology available to protect our customers and ourselves, we kind of position ourselves for success. So that's a bit about Capital One. I don't want to beat a dead horse. If you're here, you probably already know quite a bit about Capital One. So I'm going to skip to what most of the people here are probably interested in, which is what are some of the lessons learned over the years as we've improved our tech stack to scale AI. And I like to break this down into two things. A 10-year journey can never be broken down into two things, but these are the things I like to talk about. So the first is the human component, which is enabling cross-functional partnerships. And then the second, which is kind of the technical component or the machine component, is investing in platforms and modernizing our tech stack. So you can think of this as like RoboCop. There's the human and there's the machine component, and if they're working together, you sweep the streets of Detroit of crime. So talking about cross-functional partnerships, when you go down to the atomic level, you can think about, for example, an individual research team. So what is the makeup of a research team? The first thing is we might want a diversity of perspectives, and this is useful for a number of reasons. One, when you're trying to figure out what problems to solve and how to solve them, you want to attack the problem from multiple directions. But another key tenet of Capital One is we want to scale AI responsibly and in a well-managed way. And when you're trying to do that, having a bunch of very smart people with different perspectives looking at the problem helps you anticipate and catch problems that you otherwise might overlook. And so what a research team at Capital One, like the one I work on, might look like is you might have data scientists. They're the best, mostly because I am one. These are individuals who are, for example, obsessed about the data. What data should we use? What data can we use? How should we use it? How should it be structured? Where does it go wrong? Data goes wrong all the time. I think data is cursed. It's like a broken mirror. Anyone that gets their data right, wait a little while. It'll be wrong. There are also individuals who are kind of obsessed about how the research will be integrated into use cases. So a lot of what I do as a data scientist on the research team is going out and thinking about what is the prior art in our business to solve the problems relevant to finance. and how can the research we're doing be applied to enhance those existing solutions. You also have engineers, machine learning engineers, data engineers, and software engineers. And this, I think, is really important for a research team because it kind of prevents one of the main failure modes that you see on teams developing AI, which is they do amazing research, and that's it. You want to have the ability to port whatever you're doing in the machine learning world from ideation into deployment. And so having an integrated team where you have data scientists as well as engineers ensures that you are building and designing with deployment in mind, and you have a path to actually getting something in market. It's the applied part of applied science. You also have your business and product partners. These are individuals which are helping connect your team to other relevant teams, and I'll talk a bit about that in a moment, and also helping to align the research to whatever the strategic priorities of the company are. And this helps prevent kind of the other failure mode you can see in research teams, which is you do amazing research and your enterprise doesn't care. It's not relevant to the strategic priorities that you have a mandate to solve. You also have applied researchers who are working with the data scientists. And these are often individuals who are not just looking across the company, but looking at the literature and trying to find what are the ideas outside the company that we are going to bring in. And a lot of the work that the behavioral models team I work on, what they do is trying to connect what is the latest and greatest outside of our company to the business problems our company is most interested in solving, either to improve the efficiency of our associates or improve the experience of our customers. But we can zoom out from the atomic level and think about how do teams work with each other. And again, the theme is cross-functionality. So the research teams are going to be working, I like to think of it as a triumvirate with our lines of business. So these are the teams whose everyday business is solving one part of what we do. So these are individuals who, they really understand this class of credit products, auto loans. These are the individuals that support some of the amazing products that are customer-facing, like our Auto Navigator product, where customers can go online and be matched to a car and be pre-qualified for financing. These are individuals who can talk to us about what are the problems relevant to their business, what are the gotchas or catches that we might not be aware of. These are individuals that can say, here's the prior art and the data we're using to help make sure that as we're doing research, we can connect that research to something that, in Capital One, we say moves the needle. Another really important partner that we have are our risk teams and compliance teams and legal teams. And I've said that as we scale AI, a big part of that is being well-managed and responsible. And so from ideation to deployment, we're working with our risk teams to understand what are the best practices that we need to follow to make sure that our research is aligned with our company values. And the first thing people say when I say that is, oh my gosh, how much time do you spend in meetings with your risk partners? Not as much as you'd think. But really what this is about in terms of being cross-functional is, as early as possible, align strategically with risk and the lines of business so they know where you're going and they know how to engage at the right time in the right way. The worst thing you can do is invest your heart and soul in research that you think will make a difference, and then at the last moment realize you've missed something or you've set up the problem in a way that just doesn't make sense for the business. And that triumvirate, of course, is an oversimplification of a much more complex problem. We like to say innovation is a team sport. I like to say no one likes to innovate in an echo chamber. You can tell I've worked at a bank for a long time. I have infinite buzzwords and slogans to throw at you. But really, there are a number of partners that come together to make research happen. So we've talked about our risk partners, and we've talked about lines of business. There's also a considerable amount of infrastructure, which I'll talk about, that enables research. When we get to the modernizing the tech stack component, I'll talk a lot about certain strategic investments we've made. But the teams that have helped us make those investments are, for example, our data producers who are out there making sure that we have clean, reliable, easy to find, and well-documented data for ingestion into our models and use in analytics. We have our platform partners, who I am going to slather in praise in this talk for building a robust foundation in which we can do cutting-edge research, and who work very closely with the research team to understand what are the unique engineering needs of a research team in this day and age, especially as the amount of data we train it on increases and the size of our models is much larger. We also have our recruiters in HR, which are tirelessly at work helping to grow our base of 14,000 technologists. And as we think about how to engage with these partners, again, the theme is engage early and often so they know where are we going and why and can get involved. And research and design with deployment in mind. So we're always thinking about really where's the research going, maybe not obsessing about monetizing immediately, but understanding what is the long-term value that we're trying to drive through our work. So I'll try not to beat this into the ground, but this diversity of thought that we get through partnerships with our business teams and our risk teams and other research teams is really a core tenet of not only scaling in AI, but doing it in a well-managed way. But I also don't want to imply that that diversity of thought stops at the walls of Capital One. So one of the strategic investments we've made is going outside of our walls and forming partnerships. One of those partnerships are partnerships with top-tier academic universities who are helping us engage in novel research to solve problems relevant to finance and to Capital One. But in addition to these academic partnerships, we also have partnerships with, for example, companies like AWS, who are helping us understand how to solve problems with, for example, how to effectively use the cloud to achieve our goals and build a foundation, a tech stack, organize our data in a way that we can do research effectively. So that's probably a great segue to start talking about platforms and how we've modernized our tech stack. So there are a number of investments we've made over the past 10 years or more that have kind of led us to a place where we can more easily engage in scaling AI. I'll highlight just a few of these, but the first one was going all in on the cloud. I can't tell you how amazing it was to go from working with on-prem servers and proprietary code to an environment where there is considerably more flexibility and freedom to build for the problem that we needed to build for rather than trying to continually work inside whatever box had been predefined. We also modernized and standardized our data ecosystem. A data ecosystem that was quite federated and not standardized was difficult to navigate. As a data scientist, I often felt we were using the data that was already available, which is a horrible way to innovate. And by standardizing and modernizing, having things like consistent metadata, it was much easier to find new data that might be relevant to a problem, to get access and be able to pull that data effectively and reliably, to have the data in training match the data that we intended to use in production. And as I mentioned, even the little things like making sure that we really understood the timestamps of the data, the format of the data, that the assumptions we were making in conducting our research would hold when we deployed that research or brought it to production. We also built out an impressive array of talent across multiple disciplines to tackle these problems, not only maintaining but growing and building new capabilities. And then last year, and the reason for this talk is we made the decision, strategic investment to deploy AI at scale, integrating it throughout our business, and not just integrating AI, but pushing the boundaries and actively engaging in research, novel research, to solve problems relevant to AI in finance. So there's a point last year where the behavioral models team started to work with a scale of data and models that we hadn't previously. And I did the wonderful data science thing of sitting down with my platform partner and saying, I have a shopping list. And as a former machine learning engineer, that's always a daunting thing to hear because you know that means a lot of work. And I talked about the HPC, high-performance compute environment that we thought we needed. And we had an honest conversation about the gaps of what our environment looked like today and where we needed to go. And there were a long list of things that I thought I wanted. And to my surprise, my platform partner said, well, you forgot about these other things. And we started to invest in expanding the capabilities of these platforms, not only to support the models that we were currently using, but the models that we expected to start using in the future. But I don't mean to imply that this was just about having the cooler instance or the bigger instance or the flashier software. I found that our research team was also going through a cultural change in terms of how we used those tools. While a lot of data science happens in notebooks, and we continue to use notebooks within our workflow, there was the idea that with these new tools, we had to be more efficient. We had to think more about scalability and reusability. We ended up using tools like Kubeflow to create these reusable pipelines represented by, for example, this DAG, so that we could conduct larger experiments more quickly and really understand where the bottlenecks in the infrastructure were. Because a lot of the limitations of the research we were doing were things like inefficient memory usage, compute usage, bottlenecks moving large amounts of data between different cloud components. And so our data scientists ended up becoming better engineers. And I think our engineers ended up becoming better data scientists by working together to solve these combined problems. And so in a year, approximately, we had essentially rethought how we train models. And we'd come up with a system which built on, but grew beyond the platforms we had before. So now we were able to do multi-node, multi-GPU training at a scale we hadn't previously. We had access and knew how to effectively use instance types that we previously had not been working with regularly. We had an SDK built on top of this compute that allowed us to do things like gracefully fail when there were hardware errors, which sounds like a very basic thing, but when you've moved to a world where you're training on tens or hundreds of GPUs, not for hours, but for days or weeks, learning to gracefully handle a GPU failure and then restart becomes a huge boon to being able to research more quickly and iteratively. And so, looking at two snapshots, last year we had multiple research teams boxing with each other over this one cluster of compute, HPC, with a relatively small number of GPUs. And now we have 5 research clusters used by a plethora of teams to conduct interesting and novel research with a quite generous amount of compute to allow us to achieve the goals, research goals that we need to. So I'll talk a little bit about some of the things we're doing with this amazing tech stack. So for the first one, I'm going to talk a bit about a problem that I've been thinking about and that our research team published an interesting paper on in Rexus not too long ago, which is the problem of trying to be personalized and proactive in your communications with your customers. And when you think about how you want to do that within finance, one way is to try to get a holistic understanding of the customer at the moment, or preferably before, that they engage with you with a problem, question, comment, or concern. And so in this paper, we talk about a specific problem which is engaging with, and I'm going to use some big terms, heterogeneous dynamic tabular data. When I was getting my physics degree, I had a professor that would yell anytime someone used big terms. He said, big terms are for small-minded people. But what I mean by this is that in finance, we often have what's called tabular data. So we have a variety of fields that are represented by columns. And then we have customers, which are rows within this data set. And I say dynamic tabular data because the rows not only represent customers, but events that form a sequence for that customer. I say heterogeneous because, as in this example, each of the event types may have a variable number of attributes. So an email may have an indicator for did you open or did you click, what was the subject line. An SMS message may have different attributes such as did the SMS bounce. And so as we're thinking about how to build models around this complex type of sequential data, we're encountering a number of really interesting problems. First, there aren't a lot of public data sets around this type of data. And second, while there is some amazing work out there, such as Vatatrans and Unitab and Tabformer, it doesn't seem like a problem that has been conclusively solved. And so it's an area that is relevant to our business and is open and ready for novel research. Another interesting part of this problem is that unlike many of the problems transformers are typically used for, which have an inherent order, there's also the component of time. So I mentioned earlier that someone had tried to commit fraud with my credit card, and the suspicious part of that fraud, or one of the suspicious parts of that behavior, was the fact that there were 3 transactions in a very short amount of time, less than a second or so. And so making sure that these models not only have a robust representation of the positions of these events within the sequence, but also the time was important. So as a data scientist, of course, I've waxed eloquent about the data science, but also after building this model, there's a whole new problem, which is actually using a model of this type. And so taking a model, a transformer model, which is, as you can imagine, joining multiple sequences of data, streaming data, data from synchronous API endpoints, and deploying it in a way that it can be used in a positive customer experience in real time is no small feat in and of itself. So we're thinking about things like using low latency streaming data. As I mentioned, it's not just low latency, it has to be high availability, it has to be fault tolerant. Thinking about what infrastructure is required for models which have more parameters than we've previously used, and which are optimized for very specific types of compute. And thinking about what are the end systems, such as our mobile app or web app, that these need to be integrated with. So this is an interesting example of how our research could be applied to customer-facing solution, we're also thinking about how to improve the efficiency of our associates. One example would be the use of Gen AI for agent servicing. So a huge theme across this conference has been Gen AI for similar applications to this, which would be, we have these 100 million or so customers who are all trying to engage with us solving problems. You can imagine we get most things right, but not everything right. So there's that one customer, going back to our grocery store analogy, who's at the point of sale, their credit card has been declined, they're very angry. They're calling our call center, and they're looking for an agent to take the right action in the moment when it matters to make sure that experience ends up as a positive experience rather than a negative one. And so using, for example, Gen AI to effectively find what is the relevant information to solve this problem and provide it to the agent in a way where they can quickly understand and then resolve the situation is immensely powerful for providing the experience we want to our customers. But again, the data science, solving the modeling part of this problem is really only the first part. There's a Herculean engineering effort that goes hand in hand with that research. And so as we think about building, for example, RAG to solve this problem of information retrieval and summarization, we are taking our data from this modernized and standardized data ecosystem. We have models that are used to generate representations of this information, which are then stored in a vector database. We also have to generate these representations on the fly from the queries in the search of the interface. We may have an additional model that's running on the fly to summarize and or re-rank the information that's retrieved from the vector database. And all of this is happening in less than a second because as this customer is on the phone and this agent is trying to resolve the problem, we want to make sure that we are having as quick a response to empower that agent as possible. We don't want the agent there waiting for the wheel of death to finish spinning. So there are a variety of lessons learned, both in terms of the data science and engineering, of trying to solve problems like this one. They'll sound quite basic. Most of them are related to logistics. But the first and most basic one, as a data scientist, I say this about any kind of machine learning, even the kind that isn't at scale, is your use case will make or break based on the data. One of the first things we realized was to create an experience that was what we really needed to meet our business goals, we needed clean and curated data. And so from the inception of the project, we invested in tools and individuals who could help us generate that data and clean up that data. For example, thinking about what tools can we use to label large amounts of text or audio data in the cloud. We also had to think about evaluation. And as I mentioned, we're not only trying to build a great solution in terms of its efficacy, but also well-managed. And so thinking about evaluation in terms of how do we make sure we're retrieving information that's relevant to the agent and the problem that the agent is trying to solve for the customer, but also how do we evaluate failure modes for these models and ways that potentially they won't fulfill the business need that we're trying to accomplish. And so this is where we set up rigorous testing, guardrails, rolling out in a phased approach so that we make sure that when this scales to more agents, it's really the experience we originally intended to develop. And I'll skip over tooling and talk about modeling because one of the lessons learned we had doing that testing and setting up those guardrails is there can be quite nuanced failure modes for this kinds of Gen AI work. And so, for example, when we were fine-tuning large language models to achieve these goals, we would find that there were nuanced failure modes depending on what the base model was, which data we were fine-tuning on, and exactly what information we were trying to achieve. And these were things that we almost certainly would have overlooked without rigorous testing and without bringing in a diversity of partners to help us evaluate what is good versus bad within the context of this use case, involving risk partners such as model governance, data governance, cyber governance, compliance, but also the end users themselves and getting perspectives from agents who we work with throughout the development process. Okay. I've left some time at the end to answer questions. This is my favorite part of the talk, audience engagement, but questions, comments, concerns about the journey that I've talked about here, the tech stack or tooling. Awesome. Thank you for having me, and I'll be around in case anyone wants to chat about Capital One or the topic. Thank you.